All right, so in these problems, hello, I'm Mrs. Short, your mom's friend. Anyway, in these problems, so make sure I noticed on number one, these percentages right here, 5%, 8%, you gotta write them like this. So anyway, so don't forget to fix that. In all these problems, you're looking for an area and you're interested in the corner of the area, right? In the corners of what's going on here. Let me get my laser. Okay, so you're interested in these corners. These corners produce the most and the least that could happen in your problem. And it's all depending on this constraint equation that they give you. You're trying to maximize or minimize. So basically all you do to maximize or minimize is you take your corners, so in this graph, 0, 0, 0, 4, and 4, 0, and you plug them into that constraint equation right there. And whichever one produces the maximum is the maximum, and whichever one's the minimum is the minimum. And so then you get your solution like right here. Okay, now don't forget that you can graph these things on Desmos. So, you can solve them for y and graph them yourself. This one right here, I could do by x-intercepts. If y is 0, then x is 5, so I got this point right here. If x was 0 and then y would be 5, I got this point right here. But then it got a little bit crazy because this one right here, when I solved it for y, it became this. So it met at some random point right there that I wasn't sure what it was. So of course you can go to Desmos and graph these things. Let's see, x plus y is less than or equal to 5. So if I get x plus y and plus, not that, sorry. And they have less than or equal to on the keyboard, or you can just do a less than and put an equal to behind it and it turns into that. And that was 5. And I forget what the other one was. I hope that doesn't go away. X 2y greater than or equal to 8. Okay, good. X plus 2y. So we got x plus 2y greater than or equal to 8. And of course, x is greater than 0, y is greater than 0. So basically what was happening right there, the area that I wanted was this double shaded region, like right here's a corner of it right there, and there's the other corner, and then the other corner is 0, 4 right here, but I can't really click on it, okay? But Desmos is nice because it gives you the corners right there, and that's what you want. So 2, 3, and 0, 5, and so when I went back to my list right here, there was my 2, 3, and my 0, 5. The other corner was 0, 4. You can also get it by doing like solving a system of equations like I did down here. I subtracted the two lines, so the x's went away. So y minus 2y became negative y. 5 minus 8 was negative 3. So I was able to solve for the point this way if you're not allowed to use Desmos. Anyway, so you plug those into your constraint equation. The constraint equation is called a constraint because usually it's dealing with like money, like you want, or something like that, like you want to spend the least money, or you get the most food, or what have you. And so when you plug those in, then this one, it does have an obvious best and an obvious worst, and so an optimal solution does exist. All right. On this next one here, definitely would advise graphing these in Desmos right here so that you could then get the corners. And remember, you just plug the corners into this problem right here. And be careful, the y and the x are switched around right there. But, this is a pretty nasty thing to graph right there. In number 9 down below, so it's a little bit hard to, you have to read it a couple times to figure out what's going on here. But at first I was going to make this one like x, y, and z, but then I started reading, and it's basically kind of based on the constraint equation. Food 1 is 35 cents, and food 2 is 42 cents. So I knew I had to make this my x and this my y, because I said I wanted to, spend the least amount of money. So I did 35 cents times x, food 1, and 42 cents times y, which is food 2. This is my constraint equation. So I want this to be the least that it can be. And notice it says do not solve. I did start solving this, and it was really gross. But anyway, so then you got your equations. They tell you that 400 units of calcium. So you have 12x plus 20y has to be 400, at least 400, and then you have the other supplement, or the other whatever, vitamins as well, or food parts as well. But anyway, and then this last one right here, so number 11, but talk about number 10 first. You want to graph these things, and basically you're looking in the area, probably the area will be over here, but it says select a point that is in the feasible region. So one of these points must be in the area that's shaded in. So like if I go back to your first problem, if you had a picture, one of those points is going to be in this area right here, and so that's what they're asking for. In number 11, they make two types of windows. So they do want to make some windows, so that's why I said x is greater than 0 and y is greater than or equal to 0. X was my regular, y was my thermal windows, and it says they can only make 135 windows a day. So that is a problem. Those are problems for me. And actually, now that I think of it, this word constraint, these might be your constraints, actually. I forget. It's been a long time since I did this. So I think, yeah, actually, you know what? These problems, these things right here are your constraints, because those are things that are like locking you in. And this is like your optimization, I forget what the particular word of the, what it's called, but that's your equation that you want to maximize or minimize. So anyway, I probably have that wrong. Anyway, you want to be less than or equal to 15,000, so $75 for every X window, $140 for every Y window, has to be less than or equal to 15,000. Over here, again, I think that constraint equation thing is wrong. But anyway, these corners right here, you plug them in. There's the one with the most or the best. So when you want to maximize your situation here, you should make 20 of one thing and 0 of the other. Okay. All right. Hope that helps. Oh, and there's the last one too, in case you wanted to look at that. Again, you can graph these things on Desmos and see the corners right there. And I think that word constraint is probably wrong. All right. Bye-bye.